Ladies and gentlemen, good morning everybody. I had the privilege to be with you yesterday, at least some of you, not all, so I'm happy to see you again. And I'm with you for, 20 minutes or so. As you see, I have no notes, so whatever can happen, could be long or short talk. I will try to stick to the 20 minutes and look to the list to give me some sign of where I'm on time. But it's really a pleasure to host you here in the very first day of the Innovating, the exhibit. You will have a busy morning this morning, so let me just try to put that briefly into perspective. The name of the event, Innovating, actually indicates we will talk about innovation. Innovation is part of our DNA, not only because we are passionate about innovation, but because we need it for the business, we need it for our customers. As you know, our customers are kind of big operators of critical infrastructures, of the transport, of security, of defense. And what they have to do, they have to fulfill a mission. They have to take decision. And they want to do that better, faster, with the constraint of safety of operation, of course, with the ultimate level of security and cyber protection, but they want to improve it. And there's no other way to improve it than by innovate for their benefit. So I would say the customer focus is, of course, our motto and our motivation to invest a lot of innovation. Of course, also for us as a company, this is a driver for our growth and our competitiveness. So it's I would say, a win-win situation where the innovation is in the middle. Now, even though everybody knows that innovation, is a kind of multi-form activity, there are a number of ways to innovate. It is also quite obvious that in a very high-tech field like Thales is working on, innovation relies very much on R&D, research and development, on innovation, on breakthrough that comes from technology, even though this is not the whole story. And they have shared already shortly with some of you yesterday, but you know that, but let's just recap some of the numbers. We are taking R&D, research and development, very seriously. We are spending 3.5 billion euros on R&D in a population of researchers and developers that is close to 30,000 people in the group worldwide. This makes of Thales one of probably most R&D intense industry in the world. And we are actually proud of it. And of course, an event like Innovating is a kind of mirror also of the results of this effort we are doing to prepare not only the delivery of the product and solution for the current programs, but prepare the day after tomorrow. I'll be back to that. So 30,000 people, they are about 10% of this population that actually invest their time in preparing the, things in 2 years, 3 years, 5 years, and so forth. So researchers, innovators for the future, I would say. Which again is quite a significant number. We know that the world is evolving. There's a number of countries, a number of organizations that are also on the research agenda. There's a lot of brain power outside. Hence, we are very committed to cooperate with the outside partners as well, and we do that very strongly. So we do cooperate with academia. We have a number of strategic partnerships, about 30, but behind these strategic partnerships, there are thousands of common projects that we deliver every year with our partners. We are cooperating very strongly and more so with startups. We have a kind of a network of about 1,000 startups that we are close to. There are 17 on the exhibit that actually participate to the demonstrator or prototyping that you will see. But there's much more behind. But also, and that's very important, we are cooperating in a new ways with the customer and the end user, in a way kind of how we can build the future together, which is all about prototyping, virtualization, quick mock-up, which is a little bit more difficult than in the consumer world because the things that we are doing are complex. They may englobe a city. So how you would prototype a city, you know, in 3 weeks, that's a challenge. So we do a lot of things on software, modeling, and so forth. And well, for those that will see a virtual cockpit, for instance, you will see how do we do that for avionics, how you can project things very quickly, very agilely to have a user experience on the spot immediately in a way. So that's an important third dimension of innovation that you might feel here and there, or at least having on top of your heads. It's very hard to summarize all the technologies that we have to master for our 5 vertical markets. You know, the aeronautics, the space, the defense, the security, and the ground transport. They are quite diverse, and we used to say that we are present from the bottom of the seas with the submarine to the extreme end of the universe. I mean, the human robot that landed on a planet that was the most far away from Earth, which actually was the satellite of Saturn, Titan, was made by Thales. That is, there was no other human-made engine that landed on a planet or a satellite that was further than Titan so far. And actually, we are all in between. The surface of the sea, on the land, in the air, in the stratosphere, on the space, and so forth, on Mars. So the breadth and the depth of technology that our 30,000 people are doing is really immense. So I will not try to summarize. But we did make a little bit of focus for these Innova Days, try to give you a hint without really neglecting some other sector, but the hint on 2 disruptive areas that are important for us: artificial intelligence and quantum mechanics, quantum devices. Quantum devices was topic of yesterday. I'll just repeat in a few sentences the summary of what we said yesterday for those that were not attending the visit. But let me start with AI. AI actually is probably the most visible part, or at least the things that people talk most on the digital transformation. You will see in the demos a lot of digital transformation impact on technology, eventually also on the business models, database, service-based, cloud-based, and so forth. So all this is in the demos. But let's talk a little bit about artificial intelligence. Obviously, we are not at all the only one talking about artificial intelligence. Probably there's a number of actors that are more talkative than we are. Probably many people believe that, you know, the game or the war on artificial intelligence is done. We know who are the winners. You know, you use it at home, you have it already. So what's the point? The point is that we are in critical systems. And to be honest, the solution that exists today, they are very much adapted for what you're using for, like make a trip forecast, or you actually order some shopping online, that's okay. Or you would like to have recommendation for what movie to look and so forth. That's okay because, I mean, the proposal is usually good and your life is not depending on it. But I can tell you this kind of AI that is behind, the algos, the implementation, you cannot put it in the critical systems. Because you will not have enough trust in it, you will not have enough evidence. So the kind of problems we want to solve is indeed how you can trust AI. Now trust not like in the book of the jungle, you know, the snake which trusts me. Okay, it's not a declarative trust. Because everybody say, I'm a fine guy, so please trust me, and you know, you have a good record track. We want to prove it. When you put an AI in aviation, you have to prove it, you have even to certify it. None of the AI that is commercially available today, that you are faced to every day, complies with these rules. You would like to also to make AI in real time on the embedded systems. There's a lot of stuff that you'll see in the demos that are embedded, remote located, autonomous. This is sometimes not depending on the cloud. You need to do it embedded. So again, a paradigm that is not yet much that covered. The third dimension, there are many, I will not go through all of them. It's not a talk about the AI as such, but there's another dimension I would just like to highlight. The majority, if not all of the buzz which is on AI is on deep learning and database. What if you don't have enough data? What if you have frugal data? And in professional world, it might occur that you don't have zillions of data. You have both cases, actually. You have things that are teraoctet in 1 hour, and you have situations where you have pure data. How you learn frugally? There's another question. Should you always rely on data? How about the domain knowledge that our customers have a lot, and we have a lot? Can we make something more efficient than it is today? More efficient, actually also power consumption-wise. The deep learning AI is one of the most power-consuming applications that you have. So if you want to burn the planet, it's a very good option. But maybe that's not exactly what we want to. So how we can actually become closer to an efficiency of the human brain, which actually makes 20 watt of power consumption, whereas a deep learning, wait for a similar function, and nobody actually is similar, we are talking about kilowatts, megawatts, whatever. You take the example that is still far away from a human brain. So how can we go closer and be more efficient in energy? So all these dilemmas is something that we tackle today. And there are more. We call this approach, this frame, true AI. This is what we are proposing to our industry to develop, and we have already proof of that here and there as you will walk through the demo. True means transparent. I mean, we believe that AI could not be kind of, black box and stay alone. Our customer and we are very committed to the man-machine dialogue, so there is a transparency. There is the U is for understandability. Our user needs to understand what the AI is doing for them. At the end, it's more a machine than intelligence. It's still a machine, but they need to know what is behind. And E for ethics, because we are very much bound to the ethics in Europe, in France, and as a company as well. And we need to embed practices that ease the respect of the ethics law. So this is true AI, and this is in a way the slogan of the Innov Days today. There are 67 demos in the demo space. 40 out of 67 have AI inside, which is a very, very high percentage. All for the B2B business. So you will not have anything that recommend you what to buy on this and this platform, right? But you will still have things that as a consumer you can use it. Okay, you will be faced to. You will discover that in your trips. So this is one angle. The quantum technology, we really spent yesterday showing the labs, which is the place where it happens today. There is a little echo of these in the demo stand. You have a quantum chip, you have things like that in the technology exhibition. But the demo per se, this was the yesterday session in a way. But let me just recall a few elements as a summary. We have been proposing yesterday with our colleagues from academia and university a few examples of how we are embarking on what is called the second generation or the second revolution of quantum devices, which means that there was a first one. And the first one, that was the laser, that's the GPS, that's the microelectronics, that's the magnetic resonance imagery and medical systems. All these four major applications, they are based on quantum physics, actually one effect, which is the fact that the atoms and the electrons or particles, they have kind of discrete levels, well-defined levels of energy. And because of that, you have very accurate clocks, which allow GPS. You have very accurate wavelengths, which allow laser, and so forth. Now, the physical phenomena that the particle encounter, which are quantum properties, there's a much bigger number of very exotic behavior than this quantification that was the core of the first revolution. So now we are at the technology level, at the stage, we can explore these new phenomena, like I will not explain, but just when you read the press, entanglement, this is a very nice quantum property, superposition of states, and others. These are the phenomena that we know for centuries from physics, but we are able to exploit them experimentally and for application only now. There are three fields of application that kind of push us to invest in this area. By the way, we are investing for a long time. This is not a recent phenomena. We knew that this is coming, by the way. So the three applications, the very first priority for us are sensors. So sensor, radar, accelerometer, inertial systems, sonar imagery, electronic wavelengths detection or spectrometer, gravimeter, and many others. The point is, without going into details, and what we showed yesterday is that the quantum physics allow, and we have prototype of that, to improve the characteristic of the sensor by orders of magnitude, 100, 1,000, 10,000. What does it improve? Sometimes the size. An antenna that was a few cubic meters will be that big as a piece of coin. A wavelength detector which was narrow in bandwidth will have 100 times better sensitivity and range. An inertial system that actually localize will be also 1,000 times better in accuracy and so forth. So of course this has an immediate business interest for us, because what we are doing, we can make strong differentiator, we can miniaturize things, we can offer to our customer an extended functionality on different platforms and with different performance. But beyond that, nobody knows, nobody can imagine what kind of application you can find when you improve something by a factor of 1,000, 10,000, what so forth. Remember the phrase of one famous CEO of one famous IT industry saying that in his belief there is a world market for 5 computers. Okay? And at that time it was true, because the cost of a computer was immense. I mean, that was, after the Second World War, it would occupy a building. And people at that time just couldn't believe, couldn't imagine that you will put in your smartphone a power that is much bigger than the power of this computer that was done at that time. And the cost was just not comparable. And imagine there are more than 5 smartphones today, and the applications, they are just, beyond imagination. I'm pretty convinced when you do this kind of breakthrough that are not about few percent, but orders of magnitude, the number of applications will be much beyond that what we are focusing in Thales on. So, like radars, radars initially, that was just for defense. Now our factory that makes components for radars, 90% of the job is for cars. And you have it in your cars, right? So who knows what will be the additional market. The second area we have been focusing yesterday was quantum communication, which actually will give the unbreakable communication in terms of security. They are coming, we are engaged. We have more than 10 years experience on that. And we briefly touch our view on quantum computing, which is coming, but in a way after these 2 applications that I mentioned. So it's just, is on the roadmap, but in a horizon that is longer. So these are kind of 2 highlights we wanted to promote during this Day. So let me conclude by giving you some numbers and some rationale for these Days beyond the 2 highlights that I mentioned. Well, I'll give you 67 demos. They are coming from different countries of Thales. It's internally, it's a kind of award to be present here. I mean, there's a lot of competition to present something. So we are running proposal days, filtering, lively discussion whether we retain or not this demo and so forth. So these are the winners in a way. Well, you will only see a few of one, but they all are important for us. But of course, they are not representing all of the things, obviously, that we are doing. We have organized that along what we call the decision chain. In the beginning, I mentioned you, in a way, what is our mission for our customer. So in a way, from a logic perspective, all these customers do the same. They will capture data from different kind of sensors. Sensor could ultimately be a people person too, a human sensor, but other sensors that I mentioned. We will do that sometimes on an embedded situation. Then we will use a communication to safely transmit these data to another point. That we will store. We'll put it in the cloud. If you use a cloud, we'll call it on embedded system if we use an embedded system. We'll use industrial Internet of Things that has a very high level of accuracy. Then we will process that. We can again process that embedded. We can process in cloud, again, depending on the situation. We will use artificial intelligence in particular, not only, but in particular at that stage. And then ultimately we will make the decision. And the decision could be an operator, could be a pilot in a plane, so one man with, equipped with information and linked to other people. It could be an information center, it could be a control center where there are dozens or hundreds of people collaborating in the tools to make a decision, which for instance is the case for a secure city. You will have surveillance centers with a lot of monitors, a lot of people controlling there, but still need to cooperate and make the right decision. So, but the final stage is man in the loop, could be mans in the loop, man in plural, or a single man in the loop, backed by all the technology and the decision-making process. So this is the general decision chain, which actually has been put in 4 clusters. Then when you see on the top, you see connectivity, sensor, and so forth. There are 4 signalization on the demo room. And this actually symbolizes the cluster of this decision chain, right? We have also taken advantage of this decision chain to integrate the activities of our colleagues from Gemalto. You know that we have this year acquired Gemalto company, which is actually bringing us a lot of know-how in security, in identification, on digital identity, and this nicely fit with this idea of end-to-end decision chain, which again, and I said it in the beginning, has to be completely secure, reliable, and so forth. So Gemalto is visible in the boost as well, and I guess you can capture the reason why we acquired this company as well. Now, this decision chain is one structure, but you can extract a journey which will be journey around aeronautics, a journey around cloud, a journey around connectivity, and these are the items that you will discover. So this is your next program, is to have a live experience with this demo along the track that we are proposed to you in a second. I wish you to enjoy the show. Thank you so much for coming. Thank you also for spending already some time yesterday and the day before for some of you. We have been very honored to receive you and very passionate about explaining you what we are doing. So enjoy the demos. I will be with you for the lunch. So we can go back with questions, and I see a few people face to face in the afternoon. Thank you again.